Welcome to the third episode of Construction. Today we'll be learning about sound. So, what is sound? Sound is a form of energy which produces a sensation of hearing in our ears. It allows us to hear, it allows us to communicate. Sound helps in communication. Sound propagates in the form of waves. Sound travels in the form of waves. Now, what causes sound? Sound is produced by vibrations made by a vibrating body. What is vibration? Vibration is the to and fro motion or back and forth motion of an object is known as vibration. Vibration is a rapid back and forth movement of a body about its mean position. So, a great example is a pendulum. This is the mean position of the pendulum. Mean position. And the bob, this is known as the bob, moves from the mean position to the extreme positions. This is one extreme position in one side, and this is another extreme position in another side. So this motion from the mean to each of its extreme positions are known as vibration. Now, so pendulum is an example for vibrating body and it produces sound. So sound is produced by vibrations made by vibrating body. Now, how does sound travel? How does sound travel? So the vibrating body or object produces a sound in the form of energy. Let's say this is the vibrating body and it produces sound in the form of energy. This is just a visual representation, it's not accurate. This is just for getting the concept understandable. Now, the vibrating body or object produces a sound in the form of energy. The vibrating body transfers this energy into a molecule close to it, probably air molecule. So into a molecule close to it. So it will transfer this energy into a molecule close to it. The air molecule also starts vibrating. Now this also starts vibrating. That whatever the molecule it also starts vibrating back and forth with the same frequency. These vibrating air molecules or whatever the molecule is pass on their vibration to the next molecule. Okay, so this pass overs the vibration or the energy to the next molecule and it also starts vibrate, and like that it goes and goes and goes until it reaches your eardrum. So if this is your eardrum, it reaches that eardrum, your ear, and inside there is a stretched membrane called the eardrum and it reaches there. So this is how the sound propagates. So here you can see an image of your ear. So this energy travels down this your ear. The outer ear is shaped like a funnel. When sound enters it, it travels down a canal at the end of which there is a thin stretched membrane. This is the thin stretched membrane. It is called eardrum. So this is eardrum. Okay, so this thin stretched membrane is eardrum. The eardrum is like a stretched rubber sheet. Sound vibration makes the eardrum vibrate. Okay, it makes the sound is coming down this narrow or this path, okay, down this canal to the eardrum, the stretched membrane, and when the sound vibration touches the eardrum, it also starts to vibrate or it makes vibrations. Now the eardrum sends this vibration into the inner ear. It sends the vibration into the inner ear, and from there this sensation goes to our brain. So this is how we humans hear. So this is a question answer. The answer is like that. How do we hear? The answer is The shape of the outer part of the ear is like a funnel. When sound enters it, it travels a canal at the end of which there is a thin stretched membrane. It is called the eardrum. The eardrum is like a stretched rubber sheet. Sound vibrations make the eardrum vibrate. The eardrum sends vibrations to the inner ear. From there, the signals goes to the brain. This is how we hear. Okay. Now, how do our voice box or larynx, voice box is also known as larynx, make sound, produce sound? So that's the next question. This is an image of a larynx or a voice box. In humans, the sound is produced by the voice box or the larynx. It is at the upper end of the windpipe. Two vocal cords are stretched across the voice box or larynx in such a way that it leaves a narrow slit. Between them for the passage of air. When the lungs force air through the slit, the vocal cords vibrate, producing sound. As you know, vibrations make sound. Muscles attached to the vocal cords can make the cords tight or loose. When the vocal cords are tight and thin, the type of quality of voice is different from that when they are loose and thick. Now, what are the mediums through which sound propagates? So, we learned how sound propagate or travel. What are the medium through which sound propagates? So, sound can propagate through any medium. Like it can propagate through air, water, or solid. It can propagate to gases, liquid, or solid, right? Okay. It propagates the fastest in soil. It propagates the fastest in solid. Now it propagates the slowest in gases. Okay, so it propagates the fastest in solid. It propagates the slowest in gases. Okay, so that is how it works. Now why do we hear thunder after lightning? So if you have you seen thunderstorms or lightnings? First the lightning will strike, then only the sound will come. There is a reason for this, and the reason is that light travels faster than sound. Okay, light travels faster than sound. Light travels in approximately 3 times 10 raised to 8 meter per second, while sound travels only at 340 meter per second. So this is why lightning comes first and the sound later. So that's just a reason for that. Now let's learn some terms related to sound waves. There are three basic quantities, that is frequency, amplitude, and time period. Okay, frequency, amplitude, and time period. So first of all, what is time period? Time period is denoted by capital T. Okay, its unit is seconds. SI unit is seconds. What is time period? Time period is time taken for doing one oscillation. Time period is the time taken to do one oscillation. So T equal to time taken by number of oscillations. So time period is time taken for one oscillation, that is time period, and its SI unit is seconds. Next, frequency. Frequency is the number of oscillations in 1 second. The number of oscillations completed in 1 second. So that is, if 20 oscillations are completed in 2 seconds, 20 oscillations in 2 seconds, then the frequency will be 10. Frequency will be 10 oscillations per 1 second. 10 oscillation per second, or 10 vibration per second. So number of vibrations completed in 1 second is known as frequency. We use the unit method to find it, and it is denoted by F, small letter f or small letter n, and the SI unit is hertz, capital letter H, small letter z, hertz. Okay, so what is frequency? Number of oscillations completed in 1 second. Hertz is named in the honor of German physicist Heinrich R. Hertz. So Heinrich R. Hertz. So hertz is a unit of frequency. Okay. So for and frequency f equals to the reciprocal of time period. F equal to the reciprocal of time period, and time period equal to the reciprocal of frequency. Okay, time period equal to the reciprocal of frequency, and frequency equal to reciprocal of time period. That is, f equal to 1 by t, or t equal to 1 by f. Now here is a question. A pendulum oscillates 40 times in 4 seconds. 40 oscillation, 40 times in 4 seconds. Okay, find its time period and frequency. Time period equals to time taken per number of oscillations. Okay, so time taken per number of oscillations, that is, time taken is 4 seconds. Time taken is 4 seconds. So 4 by number of oscillations 40, that is 1 by 10 seconds, and the unit 1 by 10. So that is 4 by 40 is 4 by 40 equal to 1 by 10, and the unit for time period is seconds. So 1 by 10 seconds. Now what is the frequency? Then what will be the frequency? Frequency equal to number of oscillations per second, per time taken, or frequency equal to 1 by time period. 1 by time period. So let's find it in both the ways. Number of time taken, number of oscillations is 40, by time taken is 4, or 1 by time period. 1 by time period equal to 1 by 10. Time period is 1 by 10, we already found that. So 1 by 10. 40 by 4 is 10 seconds, or 10, and the unit is hertz, capital letter H, small letter z, and 1 by 10 is 1 into 10, 10, and the unit is hertz, capital letter H, small letter z. So both are same, we can use both the methods. So frequency equal to 1 by time period, or frequency equal to number of oscillations by time taken. Next is amplitude. What is amplitude? Amplitude is the maximum displacement of the bob. So let's take a bob. This is its mean, and these are its two extreme positions. The maximum displacement of the bob from its mean position on either side is called the amplitude. Let this be A, B, and C. So this equal to this, which is its amplitude. AB or AC equal to the amplitude of this pendulum. Okay, or the vibration of this pendulum. Okay, so that is amplitude. amplitude is denoted by A, small letter A, and its SI unit is the same as that of displacement, which is meter. SI unit is meter. Okay, now next are some factors or characteristics of sound. There are three characteristics: pitch, loudness, and quality. And in this video we will be only learning about pitch and loudness. Quality we will learn in higher classes. This is for only its standard. So pitch is based on frequency. If the frequency is high, then the pitch is high. The sound is of higher pitch. The frequency is low, then the sound is of lower pitch. Okay. Pitch of a sound is produced by a pitch of the sound produced by an vibrating object with a low frequency is low, and the sound is called grave. Low pitch means grave sound. Now high pitch means shrill sound. Okay, the voice of children and ladies is shrill as compared to the voice of men. So children and ladies have shrill voice, while men have somewhat less shrill voice, somewhat grave voice. Okay, so that is frequency. Next is loudness. Loudness is the characteristic of sound by which a loud sound can be distinguished from a faint sound, even though both have the same pitch. So loudness has the equation: loudness is proportional to amplitude the whole squared. Loudness equal to amplitude square. So if the amplitude is higher, the sound is high. The amplitude is low, the sound is low or faint. Okay, so that is loudness and pitch. Quality we'll be discussing in higher classes. And the SI unit of loudness is decibels, or small letter D, capital letter B. Any sound above 80 decibels. Any sound above 80 decibels is painful for human ears. Okay, so the next thing is audible and inaudible sound. Our ears do not respond to sound having frequency less than 20 Hz. Can we hear every sound? No, it is impossible that we could hear every sound. We have a range of loudness and a range of pitch. Okay, so the range of frequency, audible frequency range for us, for audible loudness range is 0 decibels to 120 to 140 decibels. Anything below 0 decibels we could not hear. Anything below 0 decibels and anything above 0 decibels we could not hear that too. So that is loudness range. Now the audible frequency range for human ear is 20 Hertz to 20,000 Hertz. 20,000 Hertz can also be written as 20 kilohertz, small letter K, capital letter H, small letter Z. 20 kilohertz. 1000 Hertz equal to kilohertz. Keep this in mind. 1000 Hertz equal to 1 kilohertz. Okay, keep this in mind. So 20 Hertz to 20 kilohertz is an audible frequency range for our ears. Now anything below 20 Hertz, are known as, any sound below 20 Hertz are known as infrasound. Any sound above 20 kilohertz above 20 kilohertz are known as ultrasound. Ultrasound, infrasound, and ultrasound. Okay, and we have different uses for this. For example, sonar system, ultrasound sensors, seismograph, microphone, weapons, detectors, etc. So these use ultrasound and infrasound for working. Now the next thing is noise and music. Pleasant sound. Pleasant sounds are known as music. Okay. Now unpleasant or unpleasing sound are known as noise. Okay. Now music at high volume is unpleasant and is therefore a noise. So music can become a noise. A pleasant sound can become an unpleasant sound if it is played at very high volume. Okay, keep that in mind. And what is noise pollution? The presence of excessive or unwanted sound in the environment is called noise pollution. For example, vehicles, crackers, bursters, kitchen appliances, TV at loud volume, radio at loud volume, etc. are noise pollution. So noise pollution is presence of excessive or unwanted sounds in the environment. Okay. Now what are the harms of noise pollution? What are the harms of noise pollution? Noise pollution leads to lack of sleep, high blood pressure or hypertension, that is high blood pressure, hypertension. Then anxiety, then hearing impairments. These are some health problems caused due to noise pollution. So how can we stop this noise pollution? There are many methods to prevent this noise pollution. Silencing devices must be installed in aircraft engine, transport vehicles, industrial machines, etc. Use of automobile horns should be minimized. Trees must be planted along the roads and around buildings to cut down on the sounds reaching the residents, thus reducing the harmful effects of noise pollution. So these methods should be taken to reduce noise pollution. So that's it for this chapter. Good luck on your exams if you're having one on this chapter. See you in the next one.